Hi, good morning. Now it's 3:40 a.m. I'm recording this lecture. I woke up because of stomach pain. Okay, so next Tuesday's lecture will be on the neuromuscular junction and excitatory contraction coupling and smooth muscle. All right, so the motor neurons innervate the skeletal muscle. It makes the skeletal muscle move. The motor neurons can integrate different information that receive from different locations on the dendrites. So this information could be excitatory, like EPSP, excitatory postsynaptic potential. The information coming could be inhibitory, like IPSP, inhibitory postsynaptic potential. And then the soma will integrate different information to determine if it should fire action potential or the impulse at the axon hillock. Many of the axons of the neuron are myelinated. These yellow part are myelin sheaths that help to increase the conduction velocity, to increase the spread of action potential. Now, this is just for you to appreciate. The spatial summation, meaning the summation of the simultaneous input on the dendrites from here and also from here, different location. Temporal means time. Temporal summation is the summation of repetitive stimulation at the same location on the dendritic tree. That is a temporal summation. Okay, now this is important part. The neuromuscular junction. What is neuromuscular junction? The neurons, the axon of motor neurons, in contact with the muscle fiber through these terminal boutons. This contact of junction, where the neuron communicate with the muscle fiber, is called neuromuscular junction. And also the end plate, the postsynaptic muscle fiber, the postsynaptic site is called end plate. Typically, a motor neuron can branch and innervate multiple muscle fibers. Each of the branch ends in the neuromuscular junction or the motor end plate. And each of these enlargement, the terminal enlargement from the axons, is called terminal boutons. Okay, here's a cartoon, the enlarged picture of the neuromuscular junction. So this transmission of information is unidirectional, one direction, from the nerve to the muscle fiber in pink. Excitation of the nerve always results in excitation of the muscle. So this is a voluntary muscle. Skeletal muscle is voluntary muscle. It is always excitatory. Now, there are specific proteins in the neuromuscular junction. The most important one at postsynaptic site, that listening to the command from the nerve, these are receptor proteins. A neuromuscular junction, we have acetylcholine receptor, acetylcholine receptor itself is channel. When it's bind to its ligand, acetylcholine, it will open the channel to allow the sodium and potassium go through. And when it reaches threshold, it will trigger the action potential. All right. So this is sequential events you need to know at neuromuscular junction. When the action potential arrives from the axons, it will open the calcium, multigated calcium channels, and calcium will come in and binds to the docking site on the vesicle, trigger the vesicle to fuse with the presynaptic membrane. Therefore, the acetylcholine will be released from the postsynaptic site. These little bar structure represent acetylcholine. Kind of acetyl group in black and choline group in red. So on the step 4, acetylcholine diffuse across the synapse and bind to acetylcholine receptor on the postsynaptic membrane. So these are postsynaptic acetylcholine receptors. All right, let me see if I can point to you with arrow. Here's the acetylcholine receptor. All right. So now, when acetylcholine receptor is activated, the chytine, sodium and potassium will flux into the muscle fiber and depolarize the muscle membrane. This depolarization will contribute to the end plate potential. The end plate potential, when it reaches threshold, it will fire action potential. The action potential can travel down both directions, this way and also the other way on the muscle fiber. Okay, let's see if we can move to the next slide. Okay, these are the tools we can use, huh? See if I can turn this off. Good. Now we're going to move to the next slide. It seems my computer is frozen. Let me pause.